for you today is a pretty quick lesson on problem solving with scientific notation. Now, we've been working with scientific notation just a little bit, but what's going to really come in the most handy this year is the problem solving that goes with it. Sometimes you may need to multiply or divide numbers written in scientific notation in order to solve some real-world problems. So we're going to do just that. And there are just some mathematical tricks, I guess, that go along with this, and they're just really going to, just so you can see how the math works with the scientific notation. This is what we're going to be doing. So anyway, okay, here's our first example. A rectangular section of land will be set aside for a new wildlife refuge. Its dimensions are 5 times 10 to the 5th meters by 4 times 10 to the 4th meters. Find the area of the land in square meters. So in order to find area, we would do length times width, and in this case, it's 5 times 10 to the 5th times 4 times 10 to the 4th. Notice here that this is all multiplication. And so I want you to know that you're allowed to use the commutative property here. You can get rid of these parentheses and move some things around in order to multiply in a much more friendly way. So we can multiply 5 times 4 and we get 20. And then when we multiply 10 to the 5th power times 10 to the 4th power, there's something that we haven't talked about yet. At least I don't think so. And when you're multiplying powers that have the same base, hear me. It says make a note. When you're multiplying powers that have the same base, in this case, the bases are 10. They have the same base. You are allowed to add their exponents and keep the base. So 20 is 5 times 4, and 10 to the 5th times 10 to the 4th becomes 10 to the 9th because I've simply added 5 and 4. I'm allowed to do that here, okay? So I get 20 times 10 to the 9th. However, that answer is not in scientific notation, and I would like it to be. Why is it not in scientific notation? Because 20 is not between 1 and 10. So in order to get that into scientific notation, 20 in scientific notation is 2 times 10 to the 1st power, right? 2 times 10 is 20. 10 is 10 to the 1st power, so 2 times 10 to the 1st. So I've broken that down a little bit. So 2 times 10 to the 1st times 10 to the 9th. Again, I'm multiplying powers that have the same base. That base is 10, and so 1 plus 9 is 10. So the solution to this problem is 2 times 10 to the 10th power meters squared, because we did find area, right? And that's that. Here is another example. Whoa! 1 cubic millimeter of blood contains about 5 million red blood cells. If there are about 4,900,000 cubic millimeters of blood in Mrs. Murphy's body, how many red blood cells will there be? Well, I want you to know that there are 2 strategies here, but comprehending what you're doing is so important. Interpretation is key, and I'll talk about that in a second. So first, you can take it and make it in scientific notation, because at this point, scientific notation is your friend. Yeah? So 5 million is 5 times 10 to the 6th power. And 4,900,000 is 4 and 9/10 times 10 to the 6th power. And so in order to find out the number of cubic millimeters, I am going to multiply, because I know how much is in 1 cubic millimeter, right? And if I multiply that by the number of cubic millimeters, I will find out how many blood cells there are. So I would multiply here, and again, I would use that commutative property. And so I want to multiply 4.9 by 5 first, and so that gives me 45, and that's 24.5. So 24.5 times 10 to the 12th, because 10 to the 6th times 10 to the 6th, same base, add the powers, 10 to the 12th. Again, this is not in scientific notation, but 24 and 5/10 would be 2.4 times 10 to the 1. So really, I just kind of like add 1 to that exponent there. And in scientific notation, I would get 2 and 45/100 times 10 to the 13th. Okay, you may understand what I've just done there. If not, we'll talk about it later. But so this is the first strategy. And this is a massive number, right? I mean, if in 1 cubic millimeter there are 5 million red blood cells, how many red blood cells are you going to have in 4,900,000 cubic millimeters? I mean, it's uncanny, the amount. So the second strategy is use a calculator. Okay, so, and you can do that. What's going to happen, though, is if you use a graphing calculator, you could type in 5 million times 4,900,000, and it's going to give you this. More than likely, okay? What the heck does that mean? Well, the E that it gives you, I don't know why, I guess I really don't know why they choose E. I should have researched it before I put it on here, but I didn't. It means times 10 to the 13th power. Now, that's great and everything. If I were to get this on a test or quiz, I'd be like, you don't really know what you're doing, you just typed in a bunch of numbers. What you would need to understand is that it means this. But even beyond that, what does that mean? I mean, 2 and 45 hundredths times 10 to the 13th power. If I asked you to write that in standard form, obviously that's going to be massive, but let's kind of like play with it for a second. 13th power, that's 13 powers of 10, so that's 13 place values, right? And we are definitely talking about a positive number. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Holy cow. So what's important too are commas. Comma, 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 comma. So it'd be, let's see, millions, billions, 24,500,000,000,000 red blood cells. Huge, right? That's why we use scientific notation. I would ask you to interpret that and maybe write it in words. 24,500,000,000,000. I mean, that tells me that you have interpreted it correctly. It is key, understanding the amount. If you were to think it was negative, it wouldn't make sense. If you were to think that it was less than 1, wouldn't make sense. It's all about interpretation. And then lastly, got a little division going on here. California, which is the most populous state, has approximately 4 times 10 to the 7th people living in it. The entire United States population is about 3 times 10 to the 8th people. So about how many times greater is the population of the US than California? In order to solve here, we're going to divide the United States population by California's population to see how many times larger the entire country's population is. Just like with multiplication, how we could play with the commutative property, keep in mind how similar and how closely related division and multiplication are. With that, I'm going to show you this. I've taken 3 times 10 to the 8th and I've divided by 4 times 10 to the 7th. Notice what I can do here. Because of the multiplication, I can say that that's 3/4, or 3 divided by 4, times 10 to the 8th divided by 10 to the 7th. Interesting, right? Well, 3/4 is going to come down, and I'm going to make that 75 hundredths because that's something I know already. I'm very comfortable with that as a decimal value. 3 divided by 4, 75 hundredths. However, just like with multiplication, when I had the same base, I could add the exponents. When I'm dividing powers that have the same base, I can subtract the exponents. And it does subtract in order from top to bottom. So in this case, 10 to the 8th divided by 10 to the 7th is 10 to the 8 minus 7. And that's how you could show it on your paper. And that would be 10 to the 1. Again, just being 10. So, again, when you are dividing powers that have the same base, you can subtract the exponents. So that's what we've done here. And then in order to understand this amount, it's not 75 hundredths times 10 to the 1 times greater. 10 to the 1 is 10, right? So 75 hundredths times 10, that's 7.5. So the population of the entire United States is 7.5 times greater than the population of California. And this, in a nutshell, has just been 3 examples of problem solving using scientific notation. In class, we are sure to do much more.